In this video, we will go over Outcome 8, Component 1, which is all about solving logarithmic equations. A logarithmic equation is any equation that contains one or more logs. We can use the definition of a log to help us solve these equations. Before we get into the kind of new idea of solving equations, we want to review a concept we learned in Outcome 7, which was all about rewriting from log form into exponential form. So I'll go through number 1. In number 1 here, when I'm trying to get it into exponential form, the first thing I need to think about is which number is the base. In this case, 4 is the base, so that 4 will stay the base in exponential form. From here, the 2 and the 16 must switch spots. Since the 16 started next to the 4, I'll now put the 2 next to the 4, and the whole thing equals 16. In example number 2, my base is a 3, so I'll keep the base the same, and the 7, 29, and 6 will switch spots, so 6 becomes the exponent, and it's now equal to 729. We can use this same idea of rewriting to help us solve for missing variables. For example, in example 1, it gives me log base 25 of 5 equals 5. Now, if I had a calculator, I could just type this whole thing in and it should give me x, but I want to try and solve this by hand. So what I'm going to do is start with changing it into exponential form. My base is 25, so I'll keep the 25 the same, and then I'll switch spots with the 5 and the x, so x becomes my exponent, and this whole thing is equal to 5. Now we saw this last outcome. When my variable is part of the exponent, I will need to get my bases the same. 25 can break down into 5 squared, and if I leave 5 the same, it technically has an exponent of 1. Now that both sides of my equation have a base of 5, I'm able to cross them off, and I'm left with 2x equals 1. To solve for x, I divide by 2, and I get x equals 1/2. If you got either example 5 or 6 wrong, here are the answers with work included. So I recommend pausing the video and taking a few minutes to look over your work to try and find your mistake. Example 2 should look very similar to the ones we just worked with. The main difference is now the x is not on the other side of the equation. It's kind of stuck here with the log. To get the log and the x separated, I will again have to change forms. My base this time is 36, so I'll keep the 36 the same, and then I will switch the x and the 3/2. So my 3/2 will be the exponent, and that should be equal to x. Now what's nice is the x is by itself, but this 36 to the 3/2 is kind of crazy. So to simplify, I want to break down the base and see if I can kind of work with my exponents a little bit. 36 can break down into 6 squared. I'm going to leave the exponent of 3/2, and that's all equal to x. Earlier in the year, we learned that when I have two exponents right next to each other like this, a power to a power, I multiply. When I'm multiplying fractions, I like to have two fractions, so I like to change this 2 into 2 over 1, which helps me see that 2 divided by 2 can cancel out. I'm now left with 3 over 1 as the exponent, which is simply just 3. From here, I can figure out using my calculator that 6 to the 3rd power is 216, and I have solved for x. Here are the answers with work for number 7 and 8. So if you got either one of these incorrect, please take time to look over your work. Example 3 again looks very similar, but now the x is my base. Again, I'm going to start with changing forms. So my x is the base, and the 49 and 2/3 switch spots. So 2/3 is now the exponent, and this is equal to 49. Now this is a tricky one because in order to get rid of this fraction exponent, I actually have to use another fraction. What I'm going to do is take this entire side of my equation to an exponent, and that exponent should be this fraction flipped. So I will take it to the 3/2 exponent. To keep my equation balanced, I'll have to do the same thing to this side. Now what's nice is when I multiply these exponents right here, the 2's cancel, as do the 3's, leaving me with just x. Over here, I have 49 to the 3/2, which should look similar to the last example we saw, where I want to break down and simplify the base. 49 can break down into 7 squared. Again, I have exponents next to each other, so I multiply. When I put the 2 over 1, I can see that these 2's cancel, and I'm left with 7 with an exponent of 3. 7 to the 3rd power is 343. Here are the answers to number 9 and 10 along with the work. Again, if you got these wrong, please pause the video to check your answers. In our next and final example, we will see problems that look a little bit different. This time we will have logs on both sides of our equations. Whenever you're solving a log equation that has logs with the same base on each side, you can simply cancel out or cross off the logs. Okay, it's important that you're paying attention and making sure there's only one log on each side, and they must have the same base. For example, in example 4 here, we have log base 2 of 2x minus 3 equals log base 2 of 5x. 1 log base 2 and 1 log base 2 allow me to cancel them out. I'm left then with 2x squared minus 3 equals 5x. From here, my goal is to solve for x. Because I have x squareds and 5 and x's and just numbers, I know I'm going to have to factor. So I'm going to start with moving over this 5x. I'm going to put that 5x or minus 5x right in the middle there, so I'm all set up to factor. When I'm factoring, my first step is to take a times c. So 2 times negative 3 gives me negative 6. Now I'm looking for two numbers. They have to multiply to negative 6 and add to negative 5. That should be negative 6 and 1. Now, because my a value was a 2, I'm going to use my shortcut here, which is to take your two numbers and divide by that a value. Negative 6 divides by 2 nicely. It gives me negative 3. So one of my factors is x minus 3. 1 does not divide by 2 nicely, so I write that as putting the denominator in front of the x. So it's 2x plus 1. From here, I can take each of these factors and set them equal to 0. And then I can solve for x. So I would add 3 over here and get x equals 3. Here I would subtract 1 and then divide by 2. So I get x equals negative 1/2. Now from here, what I need to do is check my answers and make sure that I don't have any extraneous solutions. So what we're going to do is take both of our x values, plug them into our logs, and make sure that I don't get any negatives for what I'm taking the log of. I'm never allowed to take the log of a negative number, so I need to make sure that when I plug in my x's, the answer is not negative. So I'll take 2 times 3 squared minus 3. And I just like to plug that right into my calculator. So 3 squared minus 3 gives me 15. 15 is a positive number, so I'm good to go. Now I'm going to take the 1/2 and plug it in. 2 times 1/2 squared minus 3. Okay, when I plug that in, I get negative 2.5. I am not allowed to get a negative, right? I can never, ever take the log of a negative, which means this negative 1/2 cannot be one of my answers. You can stop there if you'd like. If you'd like to plug in, oh, I accidentally plugged in a positive 1/2, but it should still give me the same answer because I was squaring it. If you'd like to take your two answers and plug them into the other equation as well, you can. You should get the same answers either way. So when I take the 3 and I plug it into this equation here, just the 5x, 5 times 3 gives me 15, which again is positive. And then 5 times the negative 1/2 again gives me negative 2.5, which I cannot have those negatives. Here is the work along with the answer for number 11. Again, feel free to pause the video and check your work to try and find your mistake.